Hi friends, welcome to Sunil Engineering Academy. I am Sunil. In chemistry, we have already completed 19 classes. This is class 20. Okay, in this class, I am going to explain soaps, detergents and polymers. Soaps, detergents and polymers. Okay, first of all, soaps. Soaps. We know that these soaps are used for cleaning. And the soaps are sodium or potassium salts of long chain fatty acids. Long chain fatty acids. That is RCOONA. Okay. These soaps are sodium and potassium salts of long chain fatty acids. Example for this long chain fatty acids are stearic acid, oleic acid and palmitic acid. Stearic acid C17H35COOH. Oleic acid C17H33COOH. And palmitic acid C15H31COOH. Okay, these acids are obtained from petroleum products. These are obtained from petroleum products. Okay, soaps are nothing but sodium or potassium salts of long chain fatty acids, and the examples of this long chain fatty acid are stearic acid, oleic acid and palmitic acid. These are obtained from petroleum products. Okay, when these fats are heated with sodium hydroxide, then soaps are formed. That means whenever these fats heated with sodium hydroxide, NaOH, sodium hydroxide, then the soaps are formed. Soaps are nothing but sodium or potassium salts of long chain fatty acid. If you take sodium hydroxide, it will be sodium salt of long chain fatty acid. Okay, soaps plus glycerol. Soaps plus glycerol. Okay, that's in this way soaps are formed. Okay, and here only sodium and potassium soaps are soluble in water. Only sodium and potassium salts are soluble in water, and these are only used for cleaning purposes. Okay, and we know that these soaps do not work in hard water. These soaps do not work in hard water. Why? Because here these soaps reacts with calcium and magnesium ions present in hard water. And then the resultant forms insoluble calcium and magnesium ions. So that's why these are insoluble in water. So that's why these are not working hard water. Okay, whenever these soaps interacts with hard water, they will develop insoluble calcium and magnesium ions. So that's why these soaps does not work in hard water, but detergent works in hard water. Detergents work in hard water. Why? Because the detergents forms the calcium and magnesium ions, but these calcium and magnesium ions soluble in water. So that's why detergent works in the hard water, but soaps does not work in hard water. Okay, and here we know that the soaps are used for cleaning, and most of the dirt is oily nature, and non-oily nature dirt may be dissolves into water. but this oily nature that may not be dissolved in water. Okay, and for this, the ionic ends of soap, here, the ionic ends of soap are interacts with water, and these carbon chains interacts with oil. Carbon chains interact with oils, and in that way the soaps forms a structures called missile, very important. In this way the ionic ends of soap are interacts with water and carbon chains are interact with oil, and that the soap molecules forms the structures called missiles. Very important. These soaps are forms the missiles. These missiles helps that pulling out the dirt. Okay. Here what is the concept is that the soaps forms the structures called missiles. These are help to remove the dirt. Okay, pulling out the dirt. This is the concept of soaps. Next one, detergents. I already told that this detergent works in both soft and hard water. Because their calcium and magnesium salts solvable in water. That's why they can work on both soft and hard water. And these detergents are relatively stronger cleaning properties than the soaps. They have relatively stronger cleansing properties. Of as compared to soaps. Okay, and here the examples of these detergents are sodium lauryl sulfate, and these detergents are generally obtained from vegetable oils. Okay, and here these detergents are mainly three types: anionic detergents, cationic detergents, and non-ionic detergents. First of all, I want to discuss anionic detergents. These are sodium salts of sulfonated long chain alcohols or hydrocarbons. These are sodium salts of long chain alcohols are hydrocarbons. And examples of this ionic detergents is nothing but sodium lauryl sulfate, and these are used for household work. These anionic detergents are used for household work, and also these anionic detergents used in case of toothpaste. Okay, next one, cationic detergents. Okay, these are quaternary ammonium salts. Ammonium salts of amines with acetates, chlorides, or bromides. Or bromides. Okay, here the anionic detergents are sodium salts. Here these are ammonium salts of amines with acetates, chlorides, or bromides. Example of this cationic detergents are cetyl trimethyl, cetyl trimethyl ammonium bromide, ammonium bromide. Okay, and these cationic detergents are mainly used in case of hair conditioners. Hair conditioners. Okay, and the remaining one, first one anionic, second one cationic, remaining one non-ionic. Non-ionic detergents. As the name itself, they do not contain any ion in their constitution. They do not contain any ions. Okay, and examples of this non-ionic detergents are partially esterified compounds. Partially esterified compounds. Okay, and these non-ionic detergents are mainly used for liquid dishwashing detergents. Liquid dishwashing detergents. Next one, polymers. Next one, polymers. Okay, here we know that the word polymer is taken from two words, that is poly and second one mer. Poly and mer. These two are Greek words. Greek words. So the word polymer came from two Greek words, that is poly and mer. Poly means we know that many, and mer means part or unit. That means many unit or many parts. As the name itself, the polymer is made up of many units or many repeating units. Polymer is made of many units or many repeating units. These repeating units or one repeating unit is nothing but we can call this as monomer. Monomer. Mono means one. Mer means part. Only one part. That means we can also define this polymer is many. It is formed by many monomers. Okay. Here the repeating units. These repeating units are derived from some simple and reactive molecules. Those are called as monomers. And polymerization. Polymerization. The process of formation of polymers from monomers is called polymerization. That is the process of here monomers forms to polymers. This process is called polymerization. So the process of formation of monomers or formation of polymers from monomers is called polymerization. Polymerization. Okay. And this polymerization can occur in two manners. First one, addition polymerization. Addition polymerization. Second one, condensation polymerization. Condensation polymerization. First one, addition. Addition polymerization. In this, monomers combines together without the loss of smaller unit. Without the loss of smaller units. Smaller units. For example, these smaller units are water, ammonia, likewise. Okay. Once again, this addition polymerization is nothing but in this process, the monomers combines together. Monomers combines together without loss of smaller units. Okay. For examples of this addition polymerization, PVC or polythene or rubber. That means in this process of these polymers, there is no loss of smaller units. And second one, condensation. Okay, in this means the monomers combines together with the loss of smaller units. Here monomers combines together with the loss of smaller units. Like this water, ammonia, likewise. Okay, and examples of this condensation polymers are terylene, nylon. These are examples of this condensation polymers. Okay, the last topic in chemistry is matter. According to CBSE syllabus, that is 6th to 10th syllabus, there is less syllabus in case of matter. Okay, so I want to discuss 2-3 important points in this matter, and those are atoms. We know that the word atom has been derived from Greek word that means indivisible. That means it is the smallest particle of element. It is the smallest particle of an element. Very important bit. The smallest particle of an element is nothing but atom. And what is molecules? That is group of 2 or more atoms is called molecule. Group of 2 or more atoms called molecule. Okay, and here one more important concept is interconversion of states. I already discussed this topic in physics. Okay, here we know that the interconversion, that means the solid may be converted into liquid, and this liquid may be converted into gas, and this gas may be converted into solid, or this gas may be converted into liquid, or this liquid may be converted into solid. Here the important points are, this process is called what? Likewise, that is interconversion. If you take solid here, solid and gas and liquid. Okay, the process of this solid to liquid, is called fusion. Okay, and the liquid to gas, that is vapor or vaporization. The process is vaporization. Okay, the process of solid to liquid is called fusion, and the process of liquid to gas is called vaporization. Okay, and the process of this solid to directly gas without converting to the liquid, that is solid to directly gas, that is called sublimation. Very important. The process of conversion of solid to gas is called sublimation. And here the reversing process, that is gas to solid, directly gas to solid, this process is called deposition. Very important. Okay, and the process of this gas to liquid, that is condensation. Okay, and the remaining one from liquid to solid, this is called solidification. As the name itself, solidification. Okay, this is the interconnection of matter. Okay, very important. The process of solid to liquid is called fusion. The process of liquid to gas is called vaporization, and the process of gas to solid is deposition, and the process of solid to gas is sublimation, and the process of gas to liquid is condensation, and the process of liquid to solid is called solidification. Okay, here the name itself, it is a solidification, that is solid. Condensation, from gas to liquid means condensation. From liquid to gas is vaporization. Okay. Okay friends, the chemistry total syllabus is completed. Chemistry total syllabus is completed. Okay, if you want chemistry class 1 to 20 PDF notes, I put the link in my description box. Click on that link and download the PDF. Thank you very much for your support.